Thank you very much for coming to our second keynote speech today. We have the pleasure and the honor to welcome Professor Nakamura Shinichiro. Professor Nakamura did his PhD in engineering at the University of Tokyo. He is currently teaching at the Graduate School of Engineering at Nagoya University. He specialized in hydrology, water resource management, water history, and land infrastructure design. His research relates to the history of technological change in modern water management, and he's interested in the way Japanese engineers have transformed existing technology to make them operational and efficient. Furthermore, he analyzes the effect on society, both positive and negative, of technological transfer. So he looks at the characteristics of these processes, not only in Japan, but also in Asian monsoon region. And his last book that he kindly brought from Japan is here, is entitled Floods and Probability, a Technological and Social History of Design Flood in Modern Japan. It was published by the University of Tokyo Press in 2021. He received numerous awards for this book, such as Book of the Year Award from the Japanese Society of Civil Engineers, Award from the Japanese Association of Human and Environmental Symbiosis, Academic Publication of the Year Award from the Japanese Society of Hydrology and Water Resources. So Professor Nakamura is visiting researcher at the Japan Center since June and will stay until March next year. He's exploring the little known and little studied area of France and Japan relations in modern water management, and we are happy that he can take part to our celebration and to have him with us today as keynote speaker. And there will be also other opportunity to hear him again in March, since he will be organizing a collaborative research workshop on the environmental and technological history of water management, which will be the occasion of comparative perspective between Japan and France. And without any further ado, I should leave him the floor.
Merci Cyrian. Bonjour. I'm Shinichiro Nakamura of Department of Civil and Environmental Engineering. So I think you are wondering why you are here. Can you hear me? Yes, thank you. So yeah, actually now I'm in UASU's SS as a visiting researcher, but don't expect my French. It's really terrible. So I speak only in English or Japanese. And so as Shirian introduced me, my background is hydrology. So in Japan it's suimongaku. So however, my research topic is water history in Japan. So today I will talk about why history is very important in hydrology. So then yeah, let me start my presentation. Title is Confluence, Human Water Interactions, Past and Present. So recently, I think you well know that we are facing the very difficult situation in the water-related disasters or the climate events. For example, I think in European communities, I think you really concerned about the drought, especially. So in 2017, the water crisis in Cape Town is South Africa, but so in that time, I think they faced really water scarcity in, I think, one year or over 1 year. So this is one of the very famous cases of drought. And in addition, Japan also, we had a really serious drought in this year. especially in the Niigata and the Kanto region. So I think now in Chugoku region, also they are facing really serious drought now. So on the other hand, flood, too much water is one of the biggest issue related to water disaster. So 2021, the Germany and maybe Switzerland also, you had the really serious flooding. So essentially, maybe it's one of the effect of the climate change. And the European community is also really concerned about the flooding now. And in Japan, Japan is one of the famous hotspot of the flood disaster. The 2019, the typhoon Hagibis attacked it's East Japan, including Nagano Prefecture or the other eastern areas in Japan. So that was the really biggest turning point in our Japanese society regarding the flood protection or the mitigation. Actually, the Emirati Ministry of the Transportation and Land Infrastructure, they changed their policies after this flood. So as I told you that my background in hydrology, the hydrology is a science of water and for water issues. So the hydrology aims to study about the water movement, like right figure, and the distribution and the water cycle dynamics on Earth. So in addition, in the engineering perspective, of course, we are studying about the water resources management and sustainability in river basin, or essentially, of course, climate change should be considered higher and higher. So I don't know, do you have any images for the hydrology? So the traditional hydrology, of course, we are, how can I say, try to contribute to society, of course. And engineer, the water-related engineer or the hydrologist, they concern about such questions. First is how much flooding will be reduced if the levees are built. And they design the volume of the levees or a dike or the dam reservoirs, and they design the structures. On the other hand, how much economic benefit will the construction of the new dam produce. So in these questions, the hydrologists considered that human can operationalize the nature of water with technology or science. And so in this manner, they set several scenarios and they planned and operation the water cycle or the water resources. So the important point is, so we assume that human can operationalize the water. However, so we are the emergence of the Anthropocene, so of course the hydrologists also really concerned about how we can behave, how we can study the water cycle after the emergence of the Anthropocene. So left figure is very famous. Around 1 century, last 1 century. So industrialization have been proceeded, and so right figure is showing the graph of the temperature changes from the 1850 to the 2020. This figure is from the IPCC. So red line is showing the result of the simulation with human activities, and the bottom blue line is showing the simulation result without human activity. So I think that we have an agreement that the human activities have affected to the Earth and the water cycle. the human activity have affected, I told you that, in past century. So then, so hydrologists, we are, studying in the operation, in the sense of the operationalized water, where they studied about the water cycle or the water resources in scenario-based planning or the operation. We can call it the traditional hydrology. So in traditional hydrology, they tend to study the one direction from society to water. So however, I think historians know that in real society, human activities change water systems, and water systems change the human activities. That there is an interaction between the society and water. So last decade, 10 years ago, almost 10 years ago, it's 2010 or 11, so new discipline of the hydrology was proposed. So we are calling the social hydrology. The social hydrology aims to understand the interaction between the humans and the water system. And in this sense, they studied in the bidirectional feedback between the human and the water system. Both are. So this is very important concept. So in yesterday's Lisa's presentation, she mentioned about the interaction between the human and the animals and the materials. So I think the interaction is a very important concept in not only in history but also the other social sciences. So in last decade, we are studying about the human-water interaction, and social hydrologists, they developed a manner or a framework of study. So this framework is following the natural science manner, the typical manner. It's observation and theory and prediction and experiment. So in natural, the traditional hydrology, of course, we observe something. For example, rainfall or the water volume or discharge. It's a really natural dynamics. So, however, if we travel to the human-water interaction, of course, we have to observe. So, what observe? So, it's a history itself. History of human-water interaction. So then this is my main message is, the history is very important. It's the center of the discipline in the human-water interaction study. After that, they model, conceptualize the processes, and they translate such a processes is a model concept to the numerical model, and the numerical model enables to predict the future. Of course, the climate change studies, one of the mission is to predict the future, to contribute to the policy making or the human decisions. So then after that, of course, we will conduct experiment that compare each regions or each models, each societies. So this is already proposed framework at this time. So this framework has been applied to the social hydrological phenomena. It's a human-water interaction phenomena. So this is cases of the conceptualizing and the modeling of the human-water interaction phenomena. The left figure, it's published by our group. We tried to conceptualize the human-flat interaction. Of course, this is not really our original. We improved the model, the original model. So I didn't explain about the details, but we are applying such modeling style. So of course, in last decade, social scientists criticize so these models are really too much simplified. Real society or human-water interaction is much more complex, and so of course we know. So this is too much simplified. However, this is one of the majority when we study about the human-water interaction in social hydrology. So let me introduce you one case of the phenomenon of the human-water interaction. So Levy effect is one of the famous, most famous phenomena in our community. The definition is that many societies built or raise the levees to protect floodplain areas and therefore reduce the frequency of flooding. Because of the reduced frequency of flooding, people feel safer. It's long feeling, right? And more intense economic development take place close to the river. So bottom figure is also very famous figure made by the Sare. He is Uppsala University. And so left figure is showing the in case of the without levy technology. So in this case, the flood frequency very high, so people never develop the live in the floodplain. However, after installation of the levees or any other flood facilities, the flood frequency should be reduced. So then they started to develop the flood risk area. So it's very simple case. So I think it's very easy to understand everybody. And so actually such a phenomenon have been occurred in our water history. So this case in Vienna. So up picture is in 1830 in Vienna. I think you can see with any no levy society, and you can see the very natural water channel, water flow, and development didn't occurred. However, in 1930s, so levee system have been installed and straight in the river, and the development had started. And now, 2015, the floodplain areas have been completely changed to the city or the urban areas. So I think that not only Vienna, but also the France and Germany, other European countries, and of course in US also, we are facing such a common phenomenon itself. So of course Japan, though we experienced such a levy effect. So this case in Tokyo, so left figure is drawing as in view of the Asukayama, Tokyo. So Utaga Hiroshige drew this picture from Asukayama. He towered it. This is Tsukuba Mountain. Yeah, we can see. And so in that time, it's 1856. There is no development. It's like a wetland. There was there is a big river like Arakawa or Tonegawa, and Sumidagawa is located in this plain. So then in that time the area was a wetland like this. However, now present, so this is the same view from the Asukayama. So it's the floodplain have been complete, developed and changed into the city. Almost here should be Kitaku in Tokyo. So today I'd like to introduce our case study in Japan. So let me start from the introduction of the Japan water flood history. So this picture is one of the famous drawing in 1856, Ansei 3 flood, Edo. So this may be most serious flood in pre-modern era, I think. In that time, the Edo was damaged by flooding and the storm surge caused by the typhoon. So this was over 100,000. So yeah, so we might say that the deadliest typhoon disaster in Japan, maybe. So you know, after the modern era, the most deadliest typhoon or flood was the Ise-1 typhoon. It's in Nagoya metropolitan area. Had really serious damages. In that time, I think around 6,000 people were killed by the Ise-1 typhoon. So anyway, I wrong. This is not Japan. This is in Paris. In 1910, this is, I think you know well, the great flood in Paris. So in that time, of course, the Paris city center inundated. So surprisingly, in the same year, 1910, Tokyo also had real serious damages. So I think that this is one of the biggest flood in modern era Japan. So in that time, dead missing was over 800, and damaged houses over 5,000, and affected population was 1.5 million. I'm not sure how much population was in Tokyo in that time, but most of the Shitamachi is downtown area should be inundated, and they had really serious damages in that time. So, and I have to mention about this flood, Catherine typhoon, 1947. So just after the World War II, of course, the Tokyo had completely destroyed. And just after the 2 years after World War II, they had such a serious flooding in that time. So Tone River, the levee was broken at it's a Saitama, no, Gunma, Saitama, Tochigi, is around the Watarase confluence point. The levee was broken, and the water flowed into the Kanto plain, and the water reached to the Tokyo. So in that time, the death and missing was 1,900, and damaged houses over 300,000, and affected people is 0.4 million. So why this flood is very important in water history, Japanese water history, is after this typhoon, Catherine typhoon, the most of the regulation and the policies had changed. So for example, Japanese government decided to introduce a dam reservoir. So before this era, the dam reservoir is a not famous, popular flood protection way. However, after that, Japanese government really keen to introduce the dam reservoirs. So we can say that Japanese history with flooding. So then our society developed a really unique or a traditional flood protection system. So for example, indigenous discontinuous levee is one of the typical case in our society, Japanese society. So this is a Kasumi levee in maybe this Toyama prefecture. So as you can see white line, right? So this white line, red line now is levees. So in European countries and the other, of course, US maybe, they are using the continuous levee, right? So it's from downstream to the upstream. It should be continue. But in Japan, we had such a traditional way to reduce or mitigate the flooding. So the system is like this. During flood, the increased water level, they accept the inundation, the flooding in like a paddy field or the wetland. So this flood flowing system enable to reduce the flood water in downstream, right? So then now in our perspective, so this is very efficient and really useful to adapt to the flood risks. So in addition, the traditional community-based flood management is one of the very unique water flood control system. So this picture is from the Meiji 29, 1896 flood in Shinano River, Niigata. So this is showing that they're, trying to protect the flooding with using the, natural materials like soil and the stone. So then such traditional activities, ways, or the method have been developed in our history. So then such a community-based flood management is very important because this activities supported the indigenous levee systems. So the combination is very important, hard infrastructure and human agents. So I think that we agree that the 1868 is the starting point of changing of the water history in Japan. So because Japan opened the country and modern water technology and the policies were imported from the Netherlands. So this guy is very famous Dutch engineer. He's Johannes van Doren. So he was one engineer came from Netherlands in that time. So after their arrival to Japan, they started to survey the Japanese rivers, and they measured everything. For example, the river length and the river width and the depth, something. And they published a very famous, not famous yet in our community. They published the first modern technological manual. So we are calling the Chisui Soron. So in this manual, they introduced the science of water, so like an equation. So this Q equal BRU is the most famous and the most frequently used this equation. The Q meaning the discharge, and B is river width, R is the depth, U is the velocity. So, but the unit is very interesting because they are using the shaku, not meter, it's shaku. So in addition, they also applied the large scale machines to improve the river channel. So of course, such a large machinery works had a big impact to the river nature. So this is one of the example of the first Japanese modern river improvement. So this case is Taisho 2, 1913, in case with the Yodo River Improvement Project. So I think you can see the blue lines. It's a natural river channel. The red line is installed modern continuous levee, red line. So as you can see, they try to straighten the river channel with installation of the levees. So then we can say that modern continuous levees and the straightening of the river channel. Oh, so Vienna also and the Netherlands also they are using the same way, and it's the indigenous levee or the system have been replaced from the such a natural, the indigenous system to the modern system. Then now, present. So this picture is in Nagoya city. So the 50% of the people and 75% of the total property in Japan are in flood risk area. As we can say that this is a very, very typical levee effect which occurred in whole Japan. So how we can understand such a transformation from the indigenous system to the modern system? So this should be the big challenge in not only history but also the hydrology and or the human water interaction studies. So let me introduce one case study from the Kiso River Basin. The Kiso River Basin is really close to the Nagoya city. The Kiso River is very, very famous in our community because they have a really typical indigenous ring levee system. Ring levee system is one of the indigenous discontinuous levee system. So maybe you can see the, oh, I cannot use, okay, here is a ring and here is a ring. So this is a really traditional one. So this drawing is from the Horeki 5, 1755. So the very famous merchant in Gifu, the Takagike, they had a role to improve the river channel in Kiso River Basin. In that time, they surveyed the river system, the Kiso River, and they, have such many maps in their library. So in that time, the 19th century, the over 80 rings was existing in that time. So then, how the such a indigenous levee changed into the modern system. So first of all, I'd like to mention the turning point of the transformation history. It was the Anpachi flood, 1976. So this is I think that people who live in Nagoya or Gifu, so you know so this flood, the Anpachi flood, is one of the very famous flood in our region. So how we can approach such a question? So we applied the historic database analysis in this time. That we digitalized 118 maps and convert to the spatial data with using the geographical information system. And the right figure is showing our result that we completely, digitalize and convert the paper map to the digital map. That we use such historic maps like a survey bureau, the army, the department, the general staff headquarters, or something like that. So so then such data enable to analyze the transition or the trend of such a transformation phenomena. So this figure is showing the trend in the levee length and the period classification. So red line is showing the length of the indigenous levee, ring levee, from the 1885 to present. So it's very interesting because the length of the indigenous levees almost became half in last century. On the other hand, continuous levee, its modern levee, became almost double. So in addition, so this figure, one of the message of this figure is that our society completely convert from the indigenous society or technology to the modern technology or society. So then, and especially in era 1 to era 2, the decreasing trend is really rapid, right? In indigenous levies. So however, after 1955, the trend stabilized like this. So then we generated question why, what happened in that time, in this period. So in Erewhon, 1885 to 1945. So in 1886, Dutch engineers started the first célébrer improvement project and the installation of the modern levies. So this map drawing is showing the plan of the project, and Johannes De Ruyke is one of the very famous Dutch engineers in that time. They planned this project and they completed this project. So I skipped several decades. Then after 1945, so in 1945, the World War II ended, and the historic flood occurred nationwide, right? Like a Catherine typhoon, or the Ion typhoon, or the Makurazaki typhoon. So I think that in the period after the World War II, so it was really unique in the period in Japan, the Japanese water history. So because we had really serious floods, series of floods, and the catastrophic damages were occurred in that time. So then, as I told you that, Japanese government decided to install the dam reservoirs, and dam reservoirs became the majority of the water control facility. Actually in Kiso River Basin, they installed Maruyama Dam, this picture, and the Yokoyama Dam. So then after the installation of the dam reservoir, of course, the flood frequency have been decreased. And in addition, the needs of the ring levies, the indigenous levies also decrease. Yeah, finally, we call that stabilization of the river levee system. In 1946, Ampach flood was occurred. So this red line is showing the ring levees in this area, and so this point is a breaking point of a levee system. Then the flood water flow into the paddy field and the villages. However, so we can see that this ring levee protected the community and the villages very clearly, right? So then the areas with remaining the indigenous ring levees were protected from the flooding, the inundation. So then the indigenous levees were re-evaluated by the society and the government, especially local government, and removal of the indigenous levees was stopped. So then such a Ampach flood was really important to consider in our water history, especially in Kiso River. So now, how much? Yeah, of course, several ring levee system remained, and we are now trying to re-evaluate the ring levee again. Yeah, because we are facing the climate change risks, and the flood frequency and the intensity should be increased. So then, such indigenous systems have been re-evaluated. However, as I mentioned that, the indigenous levee system is very efficient. However, they need the support from the community-based flood mitigation activities. So now, even after the 1945, so the traditional community-based flood management is still deteriorating. This figure, bottom figure, is showing the number of the flood fighters in Gifu Prefecture. So after the 1965, rapidly decreased the number, and now also continued the trend. So yeah, Yes. So then I introduced one case study. From here, I'd like to propose, I want to discuss with you about the challenges for the 2073 in world history, especially in Japan. So as I mentioned that, if we study about the human-world interaction, we need the collaboration between the natural science and the social science. It's a way we can call the interdisciplinary approaches. In natural science, it's a hydrology, of course, and meteorology or engineering like me, and mathematics and the computer science. So on the other hand, in social science, of course, history and the politics or sociology, economics, or the anthropology and the humanities. So we have to collaborate to understand the human-world interaction. And we already started to collaborate each other. But, so this figure is by 2018. So they analyzed the previous publications from 1970s to the 2017. And they search by word, combination, social and hydrology, or the human and hydrology, or the people and the hydrology, and the grouping by authors, the field. So this each dot is showing the author names. And they categorize, and the color meaning the categories. So hydrology should be the majority, right? So of course, the end engineering, very small. It's only 2. Why? And the civil environmental engineering, 31. And the geography is 25. And multidisciplinary is 13. And the climatology is only 2. And the meteorology is 2. And they succeeded to involve the social scientists also. For example, the governance, political and the policy studies, economics and the businesses, and the anthropology and the humanities. However, we cannot see the history here. So then this is the actual situation now. So, but as I told you that the social hydrological community really expect the historians' contributions and the historians' perspectives. However, now the collaboration is not well. So this is one of the big issue. So then we have to design that we have to think about how we can collaborate with each other, natural science and history. So fortunately, now natural scientists also really keen to study about the past, the history itself. For example, the top figures showing the relative historical changes of climate variables last 2,000 years with using the isotope observation. It's like a ring, 3 ring, and simulations. So they can provide such a very rich data, historical data, relating to climate and water. So in addition, such a numerical modeling of human-water interaction have been developed and proposed. However, of course, there are many arguments or the criticism. So because it's so too much simplified, but there is a big potential to simulate such a human-water interaction. On the other hand, in history, of course, we are studying about the history with using a document, historical document, and the maps and the images. So we have to bridge each other. So for example, history can provide the processes and the context. So after that, I have a sense of the historian, I believe. And so when we describe the history, we pick up the several components and events, right? After that, we reorganize the story of course, it's a historian way. However, in that sense, we have a sense to model the modeling in our head. So then we can completely contribute to the such a modeling on the natural science. And from natural science, they can produce or provide the model result and the simulation result. So then I think such a data-driven, not only data, but also the modeling, the academic collaboration should be the big potential. So in next 50 years. So finally, I believe that Japanese case studies or the histories have a big advantages. So because, as I told you in my presentation, our Japanese society experienced the big changes from the pre-modern system, indigenous system, to the Western, not West, it's like a really modern system with using the technology or something. And so such a big changes has been observed in the historical documents, like text and maps and other. We have very rich resources to observe such a big changes. So I'm now studying about not only Japan but also Asian countries. Thailand is one of my target of my study. So this picture was taken by me, and in 2011 in Thai flat was occurred. So in that time, so Thailand and other Asian countries also, they are using their they have a really unique flood protection systems or the mitigation systems or the ways. So how they are now facing the really big changes, rapid changes now. So then I believe that our Japanese history could contribute or provide the lessons from our Japanese history. So finally, so that is the reason why I'm here. I want to compare the Japanese historical system and the European or the French system. So I think there are differences, many differences in the system, the human model system, interaction system. So in that sense, the modeling is a very good interface to discuss about such differences between the Asian countries and the European countries. So then, how do the interaction mechanism differ between the two societies? So then, now we are planning to hold the workshop on the connection history, the early modern France-Japan hydrogen engineering history. So in the March 13 to the 14, 2024. Yeah, please join us if you like. Okay, this is summary and the messages. Modern hydrology has traditionally given itself the task of the operationalizing water. The goal of the science of the water is to manage and manipulate its nature using the scientific or technological knowledge and its technical capacities. In recent years, a very different, if not contrasting vision of what hydrology should be about is emerging in the discipline. The discipline of the history is the key of the methodological building block of this new approach. Necessity for the sustainable interdisciplinary collaboration, which can yield ways for the rich historical record of the human past to be brought to the bear on current method of the hydrological modeling. In times of the global climate crisis, historical disciplinary input can make vital differences in saving future lives and livelihood. So yes, here is the references. I published several English and Japanese paper or books and the book chapters. Please check it if you like. And finally, I'd like to express the special thanks to the Kajima Foundation, the Foundation Maison de Science de Homme, and the JSPS Kake, and the UASU SS, and the colleagues of the Université and the CRJ. Okay, thank you for your attention, and congratulations on the 50th anniversary. Thank you.
Thank you, Nakamura-san. I think you can sit here. Thank you. So we have 30 minutes for discussion, which is perfect. Thank you for giving us enough time for the discussion. So, of course, we will also take questions from the audience. I will just start with 2 quick questions, and then the floor will also be yours. Thanks for this very broad depiction of the multiple changes that occurred, not only in water management, but also in the field, in the maybe the method and how people reflected on it. Since you are interested in knowledge transfer and circulation, I would like to go back to how maybe this river management or flood control expertise, so to say, has been built and emerged. And I was wondering if before the end of the 19th century there were maybe other influences from abroad in the Japanese river management system. Of course, I think about Chinese influence maybe, or since China must have an expertise on and a long history in flood control or river management. And yeah, you mentioned the role of von Dorn's book, and I would be interested in what would be maybe earlier works on the topic, and if it was included, for instance, in books on agronomical knowledge, because it's very linked to how you also make land available for agriculture. And basically, I think the extended question behind the first question is what is the corpus we have? What are the sources we have to work on water history management in Japan in the long run?
So for example, in my observation, my target is the modern history. So then I'm not familiar with the pre-modern history. So I guess that there was a big influence from the Chinese ways or the methodology to protect or mitigate flooding. So, however, we don't know at least I don't know such a concrete collaboration with the Chinese historians, the Japanese historians. So it should be like a blue ocean, maybe, to collaborate the Chinese and the Japanese historians. So then so yesterday Rebecca talked about such a potential of the collaboration with Chinese and the Korea and Japan. I think I really inspired that such a collaboration, collaboration is a very effective to understand not only your field but also the water history of our field. Yeah.
Okay, thank you. And to go on with this question of the changes occurring at the end of the 19th century, I was wondering what would be the difference between the indigenous river management and the modern one, maybe more in its attempt or in its design, and in other words, how we can consider maybe indigenous river management. Is it really so different, or is it a question of abilities and capabilities. And I remember one of the article you wrote with the Oki about paradigm shifts and
2018.
yeah, maybe you can elaborate on that. How also there was a change in so large machine being used, but also the intent behind it to accelerate the speed of the river. If you can elaborate on this change, what would be the difference between indigenous and modern?
Differences. Yeah, it's a good question. Yeah, so for example, today's topic was flooding, but also when we study, so we consider the water allocation. For example, the irrigation water allocate to the 2 villages, right? In that case, the indigenous way, they applied experimental way. So I mean that they first allocate to the water to villages, and they observe 2 villages, and they discussed, and they develop the consensus. Oh, the volume are same, or acceptable or something. However, in my understanding, in the modern science and the technology relating water, as we can make a plan, or we can develop scenarios with using the equation. So because of, for example, we have a volume like this, and we can develop scenarios this way and this way, and we can evaluate with using the equation, like a discharge equation. If this scenario was applied, so this water volume should be like this. So I think the biggest difference between the modern and the pre-modern, so it's in my observation. So such as the experimental way or the scenario ways. So it could be the big difference. So then, so they need such a indigenous system. So I mean this continuous review system, because so they can accept uncertainty, right? So because open the review, so then we can expect where will be inundate or the flooding. So then in such experimental way, so they are considering such a uncertainty very much. However, in the modern era, actually the current present situation, we cannot accept any uncertainty. So because we have to completely control the flood water. And now current situation in Japan like that. So most of the flood plain was completely developed. So then they never accept the flood risk at this time. But now the situation have been changed. So due to the context of the climate change, and actually we experienced the serious flood in last decade. So then now we are now trying to change our mind in our society, but we are aware that it's so difficult. It's now Japanese society completely situation in the technological lock-in. So then it's so difficult to how to solve the lock-in situation for the future. Yeah.
Thank you. We will now open questions to the audience, to the floor. Shall I bring the...
Thank you so much. This is a fascinating presentation, and I really enjoyed it and learned a lot. I'm really interested in the bigger picture that you're gesturing to in your presentation, and you walked us through this really interesting breakdown of the 3 eras. And I wanted to understand a little bit more, as you just said that society is trying to change their mind, but it's hard due to a technological lock-in. And with this era 3 that you said between 1975 and 2015, it seems like there's like minds are being changed because of the example that you showed of the levees working, the indigenous levees working, reminded me of Greg Clancy's work on earthquake nations, where after the 1923 earthquake, the brick buildings had crumbled, but the Japanese buildings and the temples had stayed standing. I wonder, as you're thinking about bringing history and natural sciences together, if you have some examples already of the natural sciences approaching history as a resource. And the reason why I ask this is because in your talk so far, it sounds like when you're saying we, society's trying to do this and that, is to prevent flooding from happening. But there's another facet of that society that is the insurance companies who have something perhaps to gain from also modeling, having predictive powers and so on and so forth. And would they not also be actively pursuing the same kind of information but for different ends and purposes? And I wonder if that, thinking about how other industries use natural science data or then invite consultants to do and fill out this data for these other purposes. Maybe that's another interesting way to think about how to approach this project.
Yeah, thank you. Yeah, that's a very nice question. But so I don't have such a clear example in such a, they applied such a historical data, something like that. So social data. So however, so now, of course, Japanese government and insurance companies, they're using the hazard map. Hazard map meaning the map showing the risk of the floodplain areas. Each area is a water depth, expected water depth, or the something. So, however, so such a simulated the hazard map. It's not, how can I say, it's a really familiar, how can I say? So it's there's a big gap between the simulated result and people's feeling. So, because of course we can warming alert with using such a map which simulated by the model, but most of people haven't experienced such a flood, right? So then now historians and geographers, they're using the historic data to show that such a risk, because there's a flood was occurred actually in past. So it's one of the case with using such a historic social data to mitigate the flood risk. So I'm sure that I can get your question clearly, but but now today I talked about such a general, how we can generate such a historic data with using the historic map. But now we are trying to how we can translate such a context to the model. So now is just a starting point to collaborate with sharing the same picture. So then, yeah, this today is just proposal for you.
Now okay? Okay. Okay. I'm Yoshi Hayashi. Yoshi means good in Japanese. I'm a good man. Okay. Well, I have been working on land use transport interactions. Shinichiro has been working on water land use interactions in a sense. So land use means, say, society or people. And having heard your discussions just now, insurance would be useful. But my opinion is money, solving by money must be at the last. Okay? But the basic idea must be nature. Okay? So Shinichiro has just explained big terrain feature. My understanding of his lecture, big terrain features will not change, will not be changed. Although the surface land use may change or have changed a lot in Tokyo. His Tsukuba mountain from Tokyo. Actually, I was living there on the Tokyo side. But big terrain feature may not or must not be changed. Okay, so why not we admit big terrain feature, nature. Okay, that's the basic thing. And former time, ancient pre-post period, society did not have money, and they did not have good technology, high technology. That's why we escaped preliminarily. Okay, we have to escape because nature power is enormous. But modern society have misunderstood. By money and by technology, we can conquer nature. So that's the basic, the fundamental, the failure in thinking. Okay. Now, so before helped by money, we admit, we respect nature. Okay, then not to be say damaged by nature, we do need smart behavior. So that is also very close to the spirit of judo. You know judo? France, the big champion is here, okay? And the first Olympic champion was the Dutch, Anton Hessing, big. Well, they are, I admit, very strong. But still, small players can throw big ones, okay? Okay, sorry. I have to stop. So big, we admit, okay? But we can smartly live, particularly shrinking days of society. Okay, sorry, I talk too much, sorry.
May I just offer a clarification to my question, which was just to put into context, insurance companies now are really interested in climate change, which is why they're interested in long-term, deep-time historical data. And that's why they're contacting geologists.
Yeah.
And at my former university where I was working at the Earth Science Institute at Nanyang Technological University, insurance companies were contacting our geologists. And our geologists were then contacting us in the history department, asking if we would not collaborate to look at temple data. And so that raises a huge ethical question for us as historians. How do we deal with that information? And so I think what you're doing, embarking on this collaborative project, is enormously important. So my footnote is just, there are other people out there in industry who are doing exactly the same thing. And so how to collaborate, if collaboration is one of your goals, do you want to collaborate across industry or just within academia? Or do you want to use industry data and find a way to use that as a reference point? So these are all possible resources for research, and not to be distorted with the kind of minutia of capital choices in the present moment. But this is about the deep time climate change issues and like how you want to make your collaborative project and enrich that with what kind of source base of data.
Thank you. Yes, that's very nice and difficult question. So of course, in the industry, the insurance industry, the other industries, they're really keen to evaluate the human risks of the climate change, and they are trying to predict the in next century now. So, but they are considered, they are aware that there is a big uncertainty. So because they didn't consider any human water interaction mechanism itself in the model. So as you know, such a model was developed with using the past data, historical data. So like not discharge or the water level or the precipitations. So then, so the one with the very how can I say, industrial benefit is to that they wanted, especially the hydrologists and the climate change sciences, they want to improve the model itself very much. Then they need the historic data, not only the hydrological variables, physical variables, but also other human agent data. So then, that is what is a human agent data? So societal data is it's very difficult because, for example, so when we think about the flood risk, we have to not only the population or the cost or the damage cost or something, but also the, for example, power or the human rights or any other very complex component should be considered in the model. So if we consider such components, we need to provide such historic data of the changing of the relationship in the sense of the context of the power or the human rights or something. So then it highly depends on what we can focus on, what will we focus on, which important component in the model. So then it's in the scientific way, it's the industry, not only industry wide, the industry, but also in the science also, we need such a historic data in the society on the human agent. So but so of course prediction is very easy to understand. It's we have a big benefit. Yeah, okay, we can predict and we can use the such a prediction data when we decide something or we decide the policy or the develop policy. However, so in my main concern is, so I want to understand the mechanism itself. So how human faced or touched the water, nature of water, what is the relationship between the society and the water? So I'm not sure how we can contribute to such understanding of the human-water interaction mechanism, but so maybe, yeah, sorry, very long, it's okay. Okay, yeah.
Hi. Do you want to respond to what was? Shall we take you? Thank you. I'll bring it over in a second.
Thank you so much, Shinichiro, for a marvelous talk. My jet lag just kicked into like high gear today, so I apologize for that. Actually, in a sense, Lisa asked my question. I think insurance, which has come up a few times, is really quite interesting. And so I want to ask two questions that are unrelated. And so give you your choice of which one or neither that you want to answer or speak to. The first is, I mean, I'm interested in change over time and what drives the reduction in use of the indigenous systems. And so what is the kind of meta explanation for that shift? You know, is there a change in governance? Is there a change in the role of very large construction corporations? I think the underlying dynamic of you know, an ongoing effort to reduce risk and generate income and so on makes a lot of sense. And so I'm interested in how do we think about that in more granular or more specific terms? What are the mediators for that shift as people choose to move closer to the river? We do the same thing with ocean coasts, right? Japan has an almost armored coast, oceanic coast, which is stunning. The tetrapod industry, for example, is remarkable. So this isn't just a river question, but I'm interested in particular in the corporate question, if you might address that. The second question is probably not related and is probably closer to what interests me, and so it's a selfish question. We heard mainly about flooding, and of course, many of the dams that you are interested in are multi-use dams. They're both for flood mitigation, for agricultural irrigation use, I imagine, but also hydroelectric production. And I wonder how hydroelectricity impacts the dynamics that interest you if it becomes a central concern. So those are the two questions. Forgive me for the jet laggy, meandering question.
Thank you. Okay, first, so I think your question is there any other, how can I say, components for the story, the missing story or something like that?
Yeah, drivers. So
yeah, driver, right? Yeah.
I can imagine rural areas and rural governments under the LDP in particular getting funding via large corporations.
Yeah.
Large civil engineering projects, and that the driver is in fact a local political pork barrel politics rather than actual flight control. And I don't know, I'm curious.
Okay, so I'm engineer. So then, when we think about such a model, the biggest issue, how we can set the boundary. So now in our model, social hydrogen model, they didn't consider that such an economic trend or the political agent or something like that. So, and the political agent should be affected by the foreign relationship between the country and the country. So it's a power balance is very important. However, in this model, we ignore such a trend in the economy or the politics, which affected by in the international context. So then, this model is really too much simplified. So in my observation, in my understanding, it's very important to consider the politics and the economic trend. So now we consider it's just boundary. So then now I'm thinking that, so it's very interesting because I mentioned that the Japanese in our history, just after World War II, so we had very serious threat in the next 10 years or 15 years. It's very interesting because the European countries also had the peak of the damage just after World War II. Why? So I think that my hypothesis is war is one of the big component which we considered. Yeah, so there are many aspect should be considered. But so this is a very interesting discussion. So what we have to consider. So and as the historian have such a perspective or the argument. Yeah.
Deforestation strikes me as really important. The loss of tree cover. in the world.
Yeah. Right. Right.
There was another question.
It's actually possibly the same question as Ian, but said a slightly different way, which is, it's interesting. I'm thinking about collaboration because we do a lot of collaboration across disciplines, and so I was thinking about the mechanics of the collaborations, which also get into the expectations for the other disciplines. And I agree entirely. I think history can bring the why do people do what they do.
Mm-hmm.
So it's understanding the implementation and the experiences of the policy rather than what the aggregate data tells you. Breaks it down. But then you have potentially the complexities of historians might go here and you go there. Or you've told the funder you'll go there and the historians are like, actually we need to look at this. Right? So I guess that's one point just about those. But I guess it's also, I was thinking in my head that there's history as change over time, and then there's history as what the questions that historians ask. And I'm really interested in your thoughts and sort of how you're working with the potential for the collaborating with how historians think that might not align. And I'll just I've got some other references for you, but I'll just ask the question.
Yeah, thank you. Yeah, so your first question is, so I think that is the reason why we have such this opportunity to. So we have to design the interface, how we can collaborate. So So Alexander also he proposed data-driven collaboration is important something, but it's data is one of the method. It's one aspect to the collaboration method. So then we have to design how we can collaborate each other. So my opinion is, such a model is a causal loop model. It's a very good way to, communicate each other. So what kind of the components never missing? It's very important, and this arrow should be existing here, and it's a plus or minus, something like that. So I think that it's a very nice way to collaborate with using the such a map, the model, and it's a model-based communication. It should be one potential. So sorry, the second question is.
It was the same. Also, I was just going to mention. I don't know if you know Joel Jurgis's book, Sunburnt Country. It's a sort of combination of historians and like environmental climate data, looking at sort of multiple years of. It's about drought in Australia and temperature in Australia. But she does a really nice job of sort of bringing in the scientific and the historical methods and data.
So then, when we decide such arrow or the components, we need the evidence from the historic materials. So, yeah, so it's a very exciting, right?
My other comment was just that there are a number of European grants going live next year that are asking for interdisciplinary approaches to floods. So.
You had a last question, Alexandra, or comment? Or
That was not my intention, but yes, I do have a question. I hope it's not last. Levy effect. If we were to translate Levy effect sounds like a very safe, cushy, soft, nice, neutral term. If you were called to rebaptize Levy effect, if you wanted to give it a name that would speak its true nature according to what we now know it can be, how would you call it? Would you call it you think you're safe, but in fact you're making a mistake of your life? how would you call it? It's not a levy effect, it's a denial effect. It is a human hubris effect. It is, what is it? How would you call it?
Sorry, first I'd like to confirm what is the code?
What is?
Code, right? Code?
What would you call? どういう名前をつけた方がいいということ？
どういう名前つけた方がいい？call.
Cool.
Okay. Levy effect. So, in English, right?
どうでも。
Call. It's so difficult. Yeah. Yeah, so levy effect is a really common terminology in our field already. So, technological something like maybe, so I'm not sure.
Okay, let's start.
Sorry.
Any other questions? I guess it's tango time.
Thank you very much again.